millions of discarded electronics, phones, laptops, circuit boards, stacked, forgotten, thrown away. But what most people don't realize is that inside this waste, there's gold, tiny amounts, hidden in every device. And inside this massive recycling facility, that hidden value is extracted through one of the most advanced industrial processes on Earth. And it all begins right here. Every day, tons of electronic waste arrive from homes, offices, data centers, and factories. But not all e-waste is equal. Some devices contain higher concentrations of precious metals, especially printed circuit boards. So the first step is sorting. Workers and automated systems separate materials by type, size, and value. Phones, servers, power supplies. Because in this process, efficiency depends on precision. Before anything is processed, dangerous components must be removed. Batteries are extracted to prevent fire and chemical hazards. Plastic housings are separated. High-value components, like circuit boards, are isolated. Some facilities use robots for this stage. Others rely on skilled workers, because careful dismantling protects both the process and the people. Enters the shredder, a machine designed to break down electronics into small, manageable pieces. Circuit boards crack, metal frames twist, components are reduced to fragments. Within seconds, the complex devices become raw material, unrecognizable, but now ready for separation. mixture contains metals, plastics, and dust. The first separation begins with magnets, pulling out ferrous metals like steel. Then, eddy current systems eject non-ferrous metals, like aluminum. Copper is separated through additional processes. What remains is a concentrated mix containing precious metals, including gold. air systems remove lighter particles. Vibration tables separate materials by density. Optical systems may even identify different components based on color and reflectivity. The goal is simple: isolate the most valuable fraction, rich in precious metals, because this is where the real extraction begins. The material enters high-temperature furnaces. Temperatures rise beyond 1,200 degrees Celsius. Organic materials burn away. Metals begin to melt. Different metals separate based on density and melting point. Heavy elements like gold sink and concentrate. What started as waste is now a molten mixture of valuable metals. This is where gold begins to reveal itself. But gold is still mixed with other metals. To isolate it, chemistry takes over. The material is treated with specialized solutions designed to dissolve certain metals. Gold remains, or is selectively extracted. In some processes, gold is dissolved into solution, invisible to the eye, then carefully recovered. This stage requires extreme control, because precision determines purity, and purity determines value. Now, the gold is brought back, from liquid to solid. Chemical agents are added, causing gold to precipitate out of solution. Slowly, particles begin to form, fine, dense, metallic, gold, reappearing after being dissolved. Collected, filtered, prepared. This is one of the most critical moments in the process, where hidden value becomes visible again. recovered gold is heated again, refined further until it reaches a molten state, bright, intense, almost blinding, then poured into molds, cooling, solidifying, forming gold bars, smooth, dense, pure. What once lived inside discarded electronics is now a tangible, valuable asset. Before it's ready, the gold must be tested. Advanced instruments measure purity, ensuring it meets industry standards, often exceeding 99% purity. Because in global markets, quality is everything. Only certified gold can move forward. What was once thrown away now becomes something incredibly valuable. From forgotten devices to pure gold, a transformation driven by technology, precision, and innovation. And every day, millions of electronics are discarded, each one holding hidden potential, waiting to be transformed again.